Good morning, students. We are continuing the concepts waves. Okay, we have completed already the equation for progressive wave and equation for stationary wave. Next concept is string. We are discussing the frequency of the wave in the stretched string as well as velocity of the wave in the stretched string. Okay, come and discuss. The velocity here from you can write velocity of the wave in the stretched string velocity of the wave in the stretched string v is equal to root of t by mu, where t is the tension t is the tension in the thread, as well as mu linear density. Then mu is equal, linear density means mass per unit length. Suppose we are going to take up a string is stretched between the two rigid supports like this. Now L be the length of the string and M be the mass of the string. Then if it is plucked and released, a wave is generated. The velocity of the wave v is equal to root of t by mu, where t is the tension and mu is the linear density, means mass per unit length. So we have written like this. This is a formula. After that, we come and discuss the next two, that is modification of the equation. That modification, v is equal to root of t tension by mu. Mu is linear density, that can be written as mass by length, that is equal to tension t by mass can be written as density into volume, that is density into volume by length, that is equal to root of tension by density into volume can be written as length into area by length get cancelled. V is equal to root of t by dA. So we changed that formula in terms of density as well as area of cross section, that I am mentioning on the board. That d is the density of the string, that is material, and area of cross section of the wire. Here area of cross section A is equal pi r square also. Why we are writing pi r square? Because the wire is in the form of a cylinder. The cylinder is nothing but having area of cross section A. It is in the circular manner. That's why the area of the circle is pi r square. That is a one more formula. So third one you can write v is equal to root of t by d into A, where d is the density and A is the area of cross section. That equal to root of, what is t by A? Tension by area. We discussed already in a elasticity chapter, where force by area or here like this, tension by area is called stress. Stress is nothing but pressure, but here we have to use the word stress. Force by area, tension by area. That's why that equals stress by here density. This is a very important formula. So the velocity of the wave in the string v is equal to root of stress by density. This is a different model. So here velocity of the wave v is equal to root of t by mu in the stretched string. Stretched string means a string is fixed between two rigid supports or walls. Once it is plucked, means vibrated and releases, then it executes simple harmonic motion as well as stationary waves are produced. But it will have some velocity. The wave will have some velocity. V is equal to root of t by mu. Then next that is improved model. That means suppose a wire is suspended and a weight, somewhat a block is connected to the end of the wire. The block is kept immersed in the liquid. Then here we have to discuss some concept. Okay, come and discuss on the board that you can write. So let us consider a wire of linear density mu as well as connected to a weight like this. Suppose this is a wire connected to a weight of mass m connected to a weight and kept immersed in a fluid. So for convenience we are taking the water as a fluid like this. Now here then what will be the velocity of the wave when it is produced? అందులోంచి కనుక if is a wave is produced, then here we have to calculate the velocity of the wave. Then here we are discussing velocity of the wave v is equal to root of t by mu. In this situation, mu linear density kept constant. Why? Because linear density mu is equal to mass by length. There is no change in the mass and length even though it is immersed in the liquid. That's why we are taking mu as a constant. Then v proportional to root of t, that is proportional to root of weight. So what is nothing but tension is nothing but weight. Tension is produced in the wire because of the suspension of the block. That's why velocity is proportional to weight. When it is immersed in the liquid, then velocity v dash is proportional to w dash, root of w dash. W dash means apparent weight. When the block is in the air, it will have some weight. When it is immersed in the liquid, it will have different weight. It loses some weight according to Archimedes principle. So W is the original weight in air. W dash is the apparent weight when it is kept immersed in the fluid. That's why we are dividing the two conditions. Then V by V dash is equal to root of W by W dash. What is meant by weight? Weight is a product of mass and gravity. That's why mg by mg minus fb. What is fb? Force of buoyancy. Apparent weight is equal real weight minus force of buoyancy. That's why here you can have implies v by v dash is equal to root of mg. Mass can be written as volume into density. Volume into density of the solid into gravity by mass. Volume into density of the solid to gravity minus Fb. Volume into density of the liquid into gravity. Because we know force of buoyancy V rho g or Vdg is the formula. Force of buoyancy is equal to volume multiplied by density of the liquid multiplied by gravity. That's why implies V by V dash is equal, everything get cancelled by taking the common, ds by ds minus dl. Very important formula, where ds is the density of the solid and dl is the density of the liquid. If water is considered as the liquid, you can write v by v dash is equal to root of ds by ds minus dw. But one more condition, they will give specific gravity in the problems. That specific gravity that you can write specific gravity S is equal, that is ds by dw, that is density of the solid by density of the water. Here you have to substitute that condition. Again you can solve the problem also, where v is the velocity of the wave when the body is in air, v dash is the velocity of the wave when the body is immersed in the water. Okay, next concept is very very important for entrance orientation, that is consider a wire. Consider a wire. Some having some length, L length. It is suspended from a rigid support. Now here we are mentioning the 3 points A, B, C. A is the bottom point and C is the top point. B is the point anywhere. Here we are going to take the velocity of the wave at a distance of x from the bottom. That means suppose a wave is generated in the string that propagates in the upward direction. Let us take. Now it is at a distance of, suppose take a point B at a distance of x from A. There we have to calculate the velocity of the wave. Simple calculation. Time also. That is a very very important model. Let us discuss on the board. Now here from we can say velocity of the wave. Velocity of the wave. Velocity of the wave v is equal root of t by mu, is equal root of t by mu. There where t is the tension. Tension is produced because of the weight. That's why this is weight. That what is the weight here? We should not consider the total weight. We have to consider the weight of the AB part only, because we are calculating the value at a point B. So you should not take the total weight. So you have to take up mass per unit length. Mass per unit length. That means here this is weight can be written as mass per unit length. Mass per unit length into what is the distance from A to B? X. That's why this is X. Mass per unit length into length. That is here mass of that particular segment into gravity. Why? Because tension is nothing but weight, mg. So this is mass per unit length into length. You have to write down like this. Okay. Then that you can say by mu. Mu is nothing but linear density, mass per unit length. That is mass by length. Mass by length. Then here mass by length get cancelled. V is equal to root of gx. Very 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 important formula, where V is equal to root of gx. V is equal to root of gx. Velocity of the wave at a distance of x from the bottom, V is equal to root of gx. They will ask the time also. What is the time required to travel from A to B for the wave? That is calculating by taking the integration concept. Okay, that how it will be. Okay, let us discuss. Now, here velocity of the wave v is equal root of gx. We got it. What is velocity? We know the definition in IP level. Rate of change of displacement. That's why v can be written as dx by dt is equal root of g into x. Take left and right side. Then 1 by root x dx is equal to root of g into dt. Integrate the above equation. If it is integrated, integral 1 by root x dx is equal root g integral dt. Root g. G is a constant, so it will be separated from the integration. Then here 1 by root x, that can be written as x power of minus 1 by 2 dx into root g integral dt. X power of minus 1 by 2. We know the formula for integral x power of n. x power of n plus 1 by n plus 1. I am writing here integral of x power of n dx is equal x power of n plus 1 by n plus 1. So from here integral x power of minus 1 by 2 dx is equal x power of minus 1 by 2 plus 1 by minus 1 by 2 plus 1. That is x power of 1 by 2 by 1 by 2. X power of 1 by 2 means root x. 2 goes up multiplied by 2. So we are getting here 2 root of x. Here you can write here 2 root of x is equal root 2g into integral dt is t. Integral dt is t. That's why here t implies root 2g t is equal to root of x. T is equal to root of x by g. To root of x by g. This is a very important formula. So time required to travel from A to B is 2 root of x by g. If we consider the total length, then instead of the x you can write L. 2 root of L by g. Time required to travel from bottom to top. Bottom to the top. That is a concept. Okay.